Today I'd like to talk to you a little bit about ground loop isolators. So what they do is allow us to reduce noise on our audio signals. Anywhere where we have long runs of cable, where you have audio equipment on one side giving us our input, all going all the way along to a amplifier with a set of speakers. Because these are both connected to mains power and they're so far away, their ground will actually be at a slightly different potential, and these few volts of difference can actually introduce a hum on our signal. So to stop that, we use a ground loop isolator. They're sometimes referred to as HumBugs because they stop the hum. So what they are is just a transformer, a one-to-one transformer, which magnetically couples our cable instead. In this case, we have two, one for each of our cables here. Now, using one of these will also introduce its own issues, and its frequency response will be slightly different. So what we're going to do is we're going to test it here using the RTM3K Oscilloscope from Roden Swartz. So I have it connected up where I have my generator, which we're also probing on channel 1 here, is running through our ground loop isolator, round and into channel 2. So we're testing our input and our output, which is what these are here. Our inputs in yellow and our outputs in green. So if we turn on our generator and we go to our sweep function, we're sweeping from 10 Hz all the way up to 22 kHz, which is our audio spectrum. If we turn on our output here, we can see we're sweeping. And if we look at our output, you can see as it's increasing in frequency, we're also getting a slight gain increase. Our amplitude's changing, and that's due to these components. So a nice way to look at this is to use a Bode plot. So a Bode plot allows you to look at gain and phase shift along frequency. So again, we're using 10 Hz all the way up to 22 kHz. And if we turn this on, you can see it's plotting along here. Our gain is in blue and our phase shift is in brown. And you can see as we get up kind of past 10 kHz here, we're starting to get an increase in our gain. We're also getting a very big change in phase shift here, in and around 1.5 kHz, going all the way up here, which is 2 kHz. We can use our cursors to actually show this. So we put our cursor 1 on this point, and you can see down here, it's 1.5 kHz. And then push this button in, bring in our cursor 2. You can see here, it's 2 kHz right here in the blue. And it also shows you your difference between these, which is about 400 Hz. So yeah, that's a nice little example of using Bode plot to very easily and quickly graph a frequency response of a piece of equipment.